Learn science with fun. Welcome to Sci-Fun with MC, your friend in learning. Today, we are going to learn about distance and displacement, their difference and how to measure them. Are you ready? Let's get it on. But before we begin, let me share you a story. Mr. Distance and Mr. Displacement are friends. They both live in the same house and they work in the same office. And one day, Mr. Displacement told his friend, Mr. Distance, "You know, my friend, I'm a bit sad because every day I get zero, unlike you who gets even higher and higher, though we live in the same house and we work in the same office." Said. Now, Mr. Distance cheered up his friend, Mr. Displacement. "Don't worry, my friend. Even if I get higher and higher daily, I won't ever leave you. Don't you worry. Because I don't have any direction." Wow, what a story from two great friends. Were you able to relate with it? Now, let's find out why Mr. Displacement is sad telling that he gets zero every day, and Mr. Distance telling his friend that he cannot go anywhere. Okay, sit. Great. Let us now differentiate distance and displacement. First, distance is a scalar quantity. It means it has a magnitude only. It has no direction. While displacement is a vector quantity. It means it has both a magnitude and a direction. That is it. Distance is scalar quantity and displacement a vector quantity. Now, let's define distance and displacement according to what they refer to or what they measure. First, distance refers to or measures the length of the entire path traveled by a moving object. Again, distance refers to or measures the length of the entire path traveled by an object. Okay, the keyword is the entire path. While displacement refers to or measures the length of the shortest path between the starting point and the end point. The clue word there is shortest path. Distance, the entire path. Displacement is the shortest path. Now, let's move on with how to determine distance and displacement. Okay, first, let us have this situation. First example. Suppose this ball from this starting point moves 5 meters to the right. What do you think would be its displacement or distance? Okay, first, the ball from this point moves 5 meters to the right. What is its distance? Again, we said distance is the length of the entire path traveled by an object. So, to determine or measure the distance, we are going to measure the entire path, the length of the entire path covered or traveled by an object. So, the entire path begins from this starting point to this end point, which is 5 meters. So, the distance is 5 meters. Did you get it? Okay, now, how about its displacement? The same example. The ball from this point moves 5 meters to the right. What is its displacement? Again, we said that displacement is the length of the shortest path from the starting point to the end point. So, what is the length of this starting point and end point? It's 5 meters, right? So, the displacement is 5 meters to the right. That is how we measure displacement. 5 meters, its magnitude, and to the right, that is its direction. Okay, I hope you are getting it. Second, next example. How about if this ball moves 5 meters to the right and continues moving for another 5 meters to the same direction? So, from this point, it moves 5 meters and another 5 meters. What do you think is the distance? Again, we said that distance is the length of the entire path traveled by an object. So the entire path is 5 meters and another 5 meters. And that is equal to 10 meters. That is the distance covered by this ball. Now, how about its displacement? The same example. The ball moves 5 meters, then another 5 meters to that direction. What is its displacement? Now, we said that displacement is the length of the shortest path from the starting point to the end point. Now we are going to measure it. 5 meters and another 5 meters. So the same. The magnitude is 10 meters. Now, what is its direction? It is going to the right. So we're saying the displacement is 10 meters to the right. That is it. Now, third example. What if this ball moves 5 meters to the right and it goes back for 3 meters? What do you think is its distance and displacement? Let's determine the distance first. Okay, so again, this ball moves 5 meters to this direction and moves back for another 3 meters. What is now its distance? 5 meters plus 3 meters is equal to 8 meters. So that is the distance. Now, for the displacement, the same example. The ball moves 5 meters to this direction and moves back for 3 meters. What do you think is the displacement? So, to get the displacement, we are going to measure that is the length between the starting point and the end point. Since this is 5 meters and this is 3 meters, the remaining is 2 meters. That is the length between the starting point and the end point. And that measures the magnitude of the displacement. And the direction is, since this is the origin and it goes to this endpoint, which is here, it would be going to the right. So the displacement is 2 meters to the right. Okay, that's it. Now, another example. Suppose if this ball from this position moves 5 meters to this direction and moves back to where it came from for 5 meters. Now, what is its distance and displacement? First, the distance is 5 meters plus 5 meters. It is 10 meters. And now, for the displacement, since it moves 5 meters there and it moves back for another 5 meters, it means it went back to its original position. And if we are going to measure the length between the starting point and the end point, it is 0. So the displacement is 0. That's it. How about this? How about if the ball moves here for 5 meters and it moves upwards for 5 meters? What would be its distance and displacement? Okay, first, distance. 5 meters plus 5 meters, the distance is 10 meters. How about the displacement? We are going to measure the length between the starting point and the end point here, which is, if we are going to connect it with a straight line, it would have this direction. It is going up here. And we are going to measure how long this is and that would tell us the magnitude of displacement. So that is it. Okay? Now, another example. How about if this ball turns around, turns around, turns around, turns around, and it ended up here? What do you think is the distance? The distance would be measured following the entire path the ball had until its endpoint. That's it. But for the displacement, we are going to measure just the length between the starting point and the end point, which is here. So we're going to measure it here. And as well as its direction, we start here, going there. So the direction would be pointing towards there. Okay, I hope you learned it. Now, that is how to measure or determine distance and displacement. So, to sum it up, distance is a scalar while displacement is a vector quantity. Distance has only magnitude, while displacement has both a magnitude and a direction. Now, you are maybe asking, why are we measuring just the distance or the length between the starting point and the end point for a displacement? Why only this? That is, it is because displacement tells us the overall change in position of a motion. And that is determined, or that is, yes, that is determined by this length with a single or a specific direction. That is it. Okay? Now, you also observe that distance can never be a zero as long as it moves, while displacement can be a zero as long as it goes back to its original position. Alright, that's about distance and displacement. I hope you learned enough and understood clearly enough about distance and displacement. And before we end this, let me share you a thought. Life or a relationship is just like scalar or vector. No matter how far your life or your relationship takes you, as long as it does not have a direction, it would remain a scalar. It's up to you to put a direction to it to make it a vector. It's great. Thank you very much for watching.